Good morning all. I am Dr. V. Pugodai, working as Assistant Professor in the SRM University, Department of Mathematics. Today I am going to speak about the topic queuing theory, fundamentals of queuing theory. A.K. Erlang, 1909, he has derived the theory of probabilities and telephone conversion. All of us have experienced the irritation of having to wait in a line. Customer arrive, wait in a queue, get a service, and after a service, departure. For example, we wait in a line in a traffic jam, toll booth, petrol bunk, ticket counter, college canteen, supermarket, and so on. Why then there is a waiting? There is more demand for service that there is a facility for a service available. Why is this so? There may be a shortage of the available server. There may be a space limit to the amount of the service that can be provided. Queuing theory answers to the two questions. How long must a customer wait? How many people will form in a line? Queuing theory attempt to answer these questions through a detailed mathematical analysis. Characteristics of queuing theory: arrival pattern of the customer, service pattern of the server, queue discipline, system capacity, number of the service channel, number of the service stages. So what do you mean by customer? The term customer is used in a general sense and does not imply a necessary human customer. For example, on an aeroplane waiting in a line to take off, a computer program waiting to be run as a time shared basis. So the arrival pattern of the customer: bulk or branches, bulked, reneged, and jockey. So what do you mean by bulk or branches? So more than one arrival can be entering the system simultaneously. The input is said to be a bulk or batches. So bulk. So if a customer decides not to enter the queue upon the arrival, he is said to be a bulked. So reneged customer. A customer may enter the queue, but after a time loss patient decides to leave. In this case, he is said to be a reneged. What do you mean by jockey? Two or more parallel waiting line. The customer may switch from a one to another is a jockey. So the service pattern of the services: if the system is empty, the service facility is ideal. Service may be a deterministic or probabilistic. The service may be a single or branches. One generally think of a one customer being served at a time by a given server, but there are many situations where the customer may be served simultaneously by the same server. The service rate may depend on the number of the customer are waiting for a service. The server may work faster if seems that the queue is building up, or conversely he may get fluctuated and become less efficient. The situation in which the service depend on the number of the customer waiting is referred as the state dependent service. For example, the customer with the parallel processing, people boarding a train. Queue discipline: there are 5 types of queue discipline: first come first served, first in first out, last come first served, last in first out, random selection for service, RSS. Priority: priority can be 2 types. So first is primitive, non-primitive. Primitive: the customer with the highest priority is allowed to enter the service immediately, even if the customer with the lower priority is already in a service when the highest priority customer enters the system. What do you mean by non-primitive? The highest priority customer goes to the head of the queue but cannot get into a service until a customer presently in a service is completely, even though this customer has a lower priority. System capacity: it may be finite and infinite. What do you mean by finite? A queue with a limited waiting room, so that when the time reaches a certain length, no further customers are allowed to enter until a space become available by the service completion. So infinite: the queue with unlimited waiting room. Number of the service channel: single service channel, multiple channel, single channel system. So the customer arrived and wait in a queue, get a service. Multiple channel system: so the customer arrive, wait in a queue, but so many server and get a service after the departure. So for example, barber shop, supermarket, ticket counter. Number of the service stages: so single stage, multiple stage, single stage. The customer arrive and wait in a queue and get a service and after service departure. For example, barber shop, supermarket and theatre, multi-stage. So the customer arrive, wait in a queue, get a service. After a service, the customer again wait in a queue, get a service. After a service, they departure. So for example, medical history, account opening, canteen. Kendall's notation is denoted by A, B, X, Y and Z. A is nothing but inter-arrival time. So M is exponential and E is deterministic. EK is Erlang type K and HK is hyper-exponential type K. PH is space type. G is general. B is service time. So M is exponential and E is deterministic. EK is Erlang type K and HK is hyper exponential type K. PH is space type. So G is general. So X is nothing but number of the parallel server. It is from 1 to infinity. Y is system capacity. It's from 1 to infinity. And Z is queue discipline. It's already is 5 types queue discipline. So queuing model. So probabilistic or stochastic model. Second model is deterministic model. Third model is mixed model. So what do you mean by probabilistic model? When there is a uncertainty in both arrival rate and service rate, not treated as a customer, not known or assumed to be random variable. So what do you mean by deterministic model? Both arrival rate and service rate are constant, which is exactly known. So mixed model, when either the arrival rate or service rate is exactly known and the other is not known. So thank you.